So now we have to discuss time dilation as a real effect. We have to prove that time dilation is not a fictitious. It's not something that that is imaginary. It is a real effect. Time dilation, we know, it is a relativistic concept. To make you understand in a very basic way and easy way, let's assume, suppose I do have this watch and this I am moving or this watch is moving like this, and I do have one and another watch in this hand. The clock which is moving will run slowly as compared to the clock which is static. That is, the difference of time in between these two clocks is known as time dilation. So I can say a moving clock runs slower than a clock which is at rest. I have already proven this by using Lorentz transformation, that we know time dilation is a relativistic concept. There I have proven it in a very detailed manner. Here we have to discuss only about time dilation being the real effect. How can we prove that time dilation is a real effect, and how can we prove it really exists? For that, I will take the example of cosmic ray. So very and simplest way. We know cosmic rays, they are just present at an altitude of around 10 to 15 kilometer from our Earth's atmosphere or Earth's surface. I need not go into the details of the formation of cosmic ray, decaying of cosmic ray. For that, just understand few basic things wherein we will prove that time dilation is a real effect. So, dear students, if I take into concept cosmic ray, cosmic rays are also called, or I may say cosmic ray particles, called as mesons. We know these mesons as in the first lecture of photoelectric effect I have discussed over there, concept of mesons and their contribution to the stability of hydrogen. These mesons are the cosmic particles. So, first thing we have to remember, they are present at taking 10 kilometer as a reference distance from their surface. So I expect or I suppose that the cosmic particles or the cosmic rays are present at 10 kilometer above Earth's surface. So I can say these cosmic particles are projected. They are projected towards Earth's surface. They might be projected towards the Earth's surface with some velocity. The velocity for cosmic ray is taken as 2.994 into, that's we say multiplied by 10 to power 8 meter per second. This is the velocity of cosmic ray particles. They are present at a distance of this and they travel with this velocity. Now, dear students, we know that when there is decay of cosmic ray particle, cosmic ray particle, it decays into positron. Positron we know that is designated by E plus. It decays in this positron and travels with the speed of this. This is its speed. So if it travels with the speed 2.994 into 10 to power 8, and its average life, or I can say the total life of this positron, is only 2 multiplied by 10 to power minus 6 second. So what does this mean? A particle which moves with the velocity of this has life only this much. So can I say in its entire life, if it will be traveling, what distance a cosmic particle will cover? You will say, sir, it covers 2 into 10 to power 2 multiplied by 10 raised to power minus 6 second is its life, and its velocity is 2.994. So it will travel only a distance of its speed multiplied it by its life. So when we solve this, this comes up to be, or it this comes up to be 600 meter. So I can say, you can take screenshot for this. So I can say cosmic ray in its entire life can travel only 600, or cosmic particle in its entire life can travel only 600 meter. But we know these cosmic particles are present, these cosmic particles are present on Earth's surface also. They are present on Earth's surface also. How come is that possible? If they are present at a distance of 10 kilometer, 10 kilometer, if we convert that in meter, I will multiply it by 1000, that is 10,000 meter. They are present at a distance of 10,000 meter from the Earth's surface, but in their entire life they can only travel 600 meter. So how come is this possible that cosmic particles are present on the Earth's surface? The simple reason for this is time dilation. Time dilation. How can we prove that? We know just m, that is mass, relativistic mass, is equal to rest mass. This is, we know, Einstein's famous theory of relativity equation. This is relativistic mass is equal to rest mass divided by 1 divided by that velocity of that particle having mass m divided by c square. Just making example, this is a particle, this is at rest at right now, its mass will be taken as m naught. But when it will be moving with some velocity, I will take its mass as a relativistic mass, that is m. And the velocity it will be moving will be taken this velocity, and I can accordingly calculate its relativistic mass. So dear students, same is the case with, as I told you, that time dilation is a relativistic concept. So I can say T like this is similarly the time difference between, as I have proven in Lorentz transformation, this also you can watch that video, that T is equal to T naught divided by under root of 1 minus v square by c square. It is synchronous equation with Einstein's relativistic equation. So In the entire life it can travel this, and but it is present at a distance, it is reduced at a distance of this, but it is even though present in the surface. So how is this possible? So this answer is answered by, this question is answered by time dilation concept. So we can say t equals to t naught divided by 1 minus v square by c square. What is t naught? T naught is that time at which the same particle was supposed to be taken as rest while dealing with inertial and non-inertial frame that has been asked already discussed. So can I say t is equal to 2 into 10 to power minus 6? What is t into 10 to power minus 6? This is the average life or the lifespan of this cosmic particle divided by 1 minus v. What was the v of cosmic particle? 2.994 into 10 to power minus, sorry, 10 to power 8 divided by c, you know, that is speed of light. There is square on this. So here if we saw upon solving this, we get the value of 3.17 multiplied by, this is the time, relativistic time of cosmic particle. The relativistic time for the cosmic particle is this. And if the cosmic particle will move as per this relativistic time, that is its actual lifespan, if it is moving, if it is at static, it is at rest, even though we cannot take that as rest, its total time span will be this one. But its relativistic time span is this. So we have proven with the help of time dilation, its relativistic time is this by using its velocity and t naught. So if it will be moving with the velocity that it is possessing for this time duration, that means the distance by traveled by it will be equal to speed, that is 2.994 multiplied by 10 to power 8 into this relativistic time, that is 3.17 multiplied by 10 is per minus 5. When we will solve this, this comes to be 9491, that is round of 10 kilometer. So when there is time dilation, the relate as per the relativistic time, this is possible, that this is the reason the cosmic particles are present on the earth's surface because of time dilation. So time dilation, by this equation or by this example, we can prove it is a real effect, but do remember it is the relativistic concept of